Hi everyone, this is a quick tutorial on this lesson right here, which is finding zeros of x-intercepts, finding zeros algebraically. So let's go and click that, and we find that we get a problem that says find all the x-intercepts of the following function and write your answers as coordinate points. So we have to remember that at the end. All right, so let's rewrite our function over here. 2x squared minus 50 and x squared minus 9. So let's look at x-intercepts for graphing rational expressions. So here's a rational expression. This note is in your blog, and it tells you what a hole is, a vertical asymptote is, and a zero is. All right, and so we see here that the first thing we've done is factor these two expressions and then see if there's anything that can be canceled out. In this case, there is. Both negative 4s can be canceled out. That creates something called a hole. After we're done canceling those out, anything that's left in the numerator is a 0, and anything that's left in the denominator is a vertical asymptote. So, and there's our little rules right there. Holes are zeros for expressions that were canceled out in the numerator and denominator. Notice I misspelled that. Zeros are expressions that are only in the numerator after canceling expressions, and vertical asymptotes are expressions only in the denominator after canceling. All right, so we're looking for zeros that are only in the numerator after canceling. All right, so first we're going to use our technology to find zeros, just like we'd use our calculator. And I like calculator soup, quadratic formula calculator. There are dozens of these out on the web, and you can choose the one you want. In this case, a for our numerator is going to be 2. There's no middle term, so we're going to put 0 and negative 50 for our constant. We hit calculate, and it's going to give us x equals 5. You can see those right here. X equals 5 and x equals minus 5. All right, and I'm going to write those like they're a fraction, even though they're not really a fraction. All right, now we're going to do the same thing for the denominator. And that is going to give us a 1, a 0, and a negative 9. Oh, wrong button. That was aggravating. 0 and negative 9. Calculate. And that tells us that it's these two right here, 3 and negative 3. X equals 3, x equals negative 3. Okay, so that was our first step, finding the zeros. Our next step is to simplify. All right, so if you remember, we were looking for, is it possible to cancel things out between the numerator and the denominator? Here we find nothing to cancel. Nothing to cancel. So you have x subtract 5 and x plus 5 in the numerator. And so our rule for a 0 was in the numerator after canceling. Okay, so there's our numerator. I got my red pen out, but there's nothing to cancel. So these are going to be remaining in the numerator after canceling. So we have x equals 5 and x equals negative 5. All right, so there's our answer. We go back to Delta Math. Now, we have to remember that it said write your answer as coordinate points. All right, so x is not a coordinate by itself, but we can make an xy coordinate by putting this x into our coordinate. And because these are zeros, as they're called, that means they are when y is equal to 0. So there's our two answers, negative 5, 0, and 5, 0. Now I come over here and it says, first thing I do is this little drop-down box. There we go. All right, and notice it gives me 3 possible answers, being very temperamental. 3 possible answers, no intercepts, 1 and 2. And we have 2, so I'm going to click 2, and it gives me 2 boxes to put my answers in. And I'm going to put parentheses, 5, comma, 0, parentheses. And over here, I'm going to put parentheses, negative 5, comma, 0, parentheses. And I'm going to say submit answer. And check my answer before I hit submit and say yes. And after thinking a little bit, it gives us a nice big green check. So there you are. That's how to find zeros in rational expressions.